So this topic is all about knowledge application, because basically as we see, we are doing regression and correlation analysis, and I just want us to focus our attention by first looking on the regression aspect, regression analysis. So regression analysis there. And when we are looking on the regression analysis, we are looking on a statistical technique. Is a statistical technique. It's a statistical technique that is used. Is a statistical technique that is used to study. It is used to study the relationship. Used to study the relationship between two variables. So when we are looking on these variables, you remember when you were doing functions, we were talking about independent and dependent variables. So we are going to be looking on these two. So we are going to be looking independent and dependent variables. So in this case, we are saying there's just a statistical technique that is used to study. We are going to be looking on the relationship between the relationship that is existing between the two. I will be able to share the assumptions of regression, but I can state that you have to be looking on the linearity. When you talk about the linearity, it means that we assume that our functions must always be in form of y is equals to a plus bx, right? That is linearity. When you say there is no auto-serial correlation between the variables, we mean that the dependent variables assume not to have close relationships. And then we have multicollinearity, where we look on the predictor, which is used as the multiple regression are not significantly related. Now, you know that the error terms of this regression analysis, we say it is normally distributed and have a constant variance, but it will normally have a mean of 0. So what are types of regression analysis? Types of regression. Regression analysis, we normally have only two. One, we have simple regression analysis. Simple regression analysis. And then we have number 2, which is multiple regression analysis. I will not be able to teach you multiple regression analysis unless you advance to advanced level. When I'm teaching it, we are just wasting our time here because it has never been tested at under your level. Now, under the new review of the syllabus, when we look on the simple regression analysis, it is a regression analysis. This one, it is a regression analysis. Is a regression analysis with only one independent variable. Independent variable. So when you talk about one independent variable, it means that when you're analyzing it in this aspect, we look on it is normally demonstrated in form of, for instance, we are talking about y is equals to a plus bx, where we are discussing about our y being the dependent variable. Right? Our A is equal to the total fixed costs. Right? Total fixed costs. We have our B, which is the total variable cost. Then we have our X. These are the number of units. Number of units produced. In other terms, or you can call it independent. Independent variable. Now, in this aspect, I will just be able to elaborate this in form of a budget. And you normally find that when you are discussing about the dependent variable, for instance, if you have 10 million, you have to be factoring how many units can I be able to produce. So that is where I'm taking the 50 million, but normally factor the dependent variable, because the dependent variable will be able to determine how many units are we able to produce. That is the concept in which you are supposed to be analyzing questions. when the examiner is going to be bringing you these problems. So analyze and ask yourself, how many units am I going to be giving under a certain scenario? Now, let us look on how can we be able to get these values, because we normally have some formulas to use, where we are saying to get our B, we take n the summation of xy minus summation of x, summation of y, we divide by n, the summation of x squared minus the summation of x, and then you close your bracket squared. We have the formula we use for A, summation of y minus b, summation of x, you divide by n. It means we have to be calculating b first, because the requirement to get our A. It is a requirement to get our A. Now, from that aspect, before we do any illustration, I just want to look on how can we be able to appraising regression model, to appraise the regression model, right? So when you look on the appraising of a regression model, we are saying that one of the equation has to be developed. One of the equation, or we can say this, once an equation has been developed, we say it must be appraised, or it must be appraised, stroke evaluated for efficiency, and reliability. So that is why you normally see an examiner saying, interpret your answer when you are looking, or when you are doing any question regarding to regression and correlation analysis. Now, the following methods are normally used to appraise. The methods used to appraise regression models, One of the methods that we normally use, we are looking on the economic plausibility. And this basically is used to look on the relationship, because when you're looking on the economic plausibility, we are saying that once an equation has been developed, or when you develop an equation, there must be an explainable relationship. There must be an explainable relationship between the variables. There must be an explainable relationship between the variables. Now, for this aspect, we are going to be looking on the changes that there must be a caution, for that is for sure. And this means that if the response variable is able to change, then there must be a change in the predictor variables. Number two, we look on the goodness of fit tests. When we look on the goodness of fit test, we say it is concerned on how well a regression model, it is concerned on how a regression model, all equations fit the data. It fits the data from which it was derived. It fits the data from which it was derived. The model, we look on it in that categories. So it is normally categorized into two measures. It is normally categorized into two measures. One, we discuss about whole equation measure. Whole equation measure. Two, we look on the slope measure. When you look on the whole equation measure, it is normally concerned with coefficient of determination. Determination, normally quoted as R squared, right? We normally have standard error of estimates. denoted as SE. Then we normally have F statistic tests. F statistic test. When you look on the slope measure, we normally have coefficients of correlation. This is our R. And coefficient of correlation and coefficient of determination, they have an explainable relationship. Now, when you look on the standard error of slope, we normally have it here. Standard error of slope, which is our SB. Then we normally have hypothesis. Hypothesis testing, which is a topic of its own. We will not be able to handle it here. So it means I need just to be elaborating for you what is the coefficient of determination, standard error of estimate, F statistic test, coefficient of correlation, and then we have standard error of slope. Those are the only things that we are going to be working on. Now, I just want to start by looking on coefficient of determination, and then we elaborate about it. Coefficient of determination. So in this case, in this scenario now, so in this case, I just want to look at it, coefficient of, let us start by looking on these methods. We start with coefficient, number one. We start with coefficient of determination, right? When you look on the coefficient of determination, right? The coefficient of determination, we are saying, this is just a measure which is going to be giving an explanatory power of the model, right? This is our R squared. We say it gives an explanatory power, or it gives explanatory power of the model or an equation. So in this case, it means it is basically used to measure the variation in the dependent variable as a result of the changes in the dependent variable. So in this case, we say, when you are making the decision, we say, generally, the higher the R squared, the better the model. The better the model. Now, I just want to look on the interpretation of R squared. Interpretation of R squared. Just looking on whether I have that concept somewhere. Right? We have interpretation of R squared. And in this case, when you look on the interpretation of R squared, basically we are saying if your model is falling between 0 to 0.49, right? We say the model is poor for prediction. Is poor for prediction, right? Between 0.50 to some just give me a minute. I just want to confirm something there.
Okay.
So this should be between 0.50 to 0.59. Here we say that the model is good. The model is average. The model is average. Then we look on if it falls between 0.60 to 0.74, we say the model is good for prediction. But if it is above 0.74, if it is above 0.74, we say the model is very good. We say the model is very good for prediction. Those interpretations we are going to be saying them as we move on. Now, from there, we just want to look on. We just need to be looking at how can we be able to get our R squared? How do we normally get R squared? So to get your R squared, you normally take explained variance, then you divide by total variance, right? So to get your explained variance, we normally do this. You normally take the summation of y predicted minus y bar squared, right? Then we divide by, to get this one, you normally take y historical minus y mean squared, right? Where our y, this one, it is normally called predicted. This one is your mean. Then this one is historical, the one that is given in the question. That is why we are calling it historical, right? Now from there, remember, when we are going to be doing our questions, we are going to be looking on all these aspects, right? We are going to be doing and looking on how can I be able to generate my R squared and so on. Now, let us look at the other model, because this we already understand how to calculate it. Number two, we can look at the standard error of estimates. Just need to be looking at standard error. Standard error of estimate, which we are calling it SE. And in this case, we just need to be talking about it, and we say it is just a variation of an estimate that can be used to obtain the confidence interval about the estimate. So in this case, when you are making your decisions, we say the lower the SE, the better the model. The better the model. Now, in this aspect, we need to be understanding that to get my confidence interval, I need to be taking the point of estimates plus or minus t or z, then you multiply by the standard error of estimates. So the biggest question is, how am I going to be getting my standard error of estimate? I will be able to say, to get the standard error of estimates, we are going to be taking an explained variance, then you divide by degree of freedom. This is DF, right? That is your DF. And I remember there before, I have told you that to get your DF, you take n minus k. So the question is, how am I going to be getting an explained variance? We normally use an ANOVA table to get that. ANOVA table, which is basically used to analyze variances. So in this case, we are going to be having, right? We normally have sources or type. Sources, we normally have sources there or type. We normally have amount and proportions. For example, here, we are going to be having, we start with the explained variance. We have an explained variance, and then we have total variances. Remember, for explained variance, umeipata wapi? Umeipata when you are doing the coefficient of determination. So this one you have. So this will be my balancing figure. Because already you have the total and you have the explained. So it means you are going to be getting, by taking explained, total minus explained to get an explained variance. Then to get your proportions, you take the total, the value for explained, you divide by the total. You get these proportions, and they should be equal to 1. They should be equal to 1. That is how you deal with the standard error of estimates. This K, these are the number of parameters. And when I look on the number of parameters here, there are only 2. So it means my K will always be 2. My K will always be 2. My K will always be 2. The next one, the next one is the F statistics test. Right? The F statistic test. Right? In this case, you need to just be able to understand that it is just a distribution which was developed by another guy called Ronald Fisher, and it is normally used to compare the explained variance sum of squares with an explained variance sum of squares. So how am I going to be getting this? You normally take explained variance, you divide by the degree of freedom. This one you denote B1. The degree of freedom is the one that you are denoting, not the whole of it. Then you divide by unexplained variance. Then you divide by degree of freedom, which is our V2, right? So to get our V1, we normally take K minus 1. V2, you normally take N minus K. That is why you see I'm just differentiating them. Now, you can also use this method, or you can use R squared, right? R squared. You divide by V1. You divide by 1 minus R squared. You divide by V2. You can just be able to get it through those methods. The other one, we have standard error of slope. Standard error of slope. And in this case, when we talk about standard error of slope, which is SB, we are discussing about a model which is basically used to measure the degree of accuracy of a slope. So this basically focuses on the accuracy of a slope. Accuracy of the slope. And we are saying generally, the smaller the SB, right? The smaller the SB, the better the model. The smaller the SB, the better the model. So how do we normally get SB? Very simple. SB, we normally take the standard error of estimates, then you divide by the root of the summation of x minus x bar squared. X bar squared. Now, the last thing that is remaining here, so that we can do illustrations and we close coefficient, we close the regression. We are discussing about here we are discussing about coefficient of correlation. This is my R, right? And you know that we said it has something, the relationship with the other one, but it is analysis which is used to assess the association, used to assess the association. It is used to assess the association of two variables. It is basically used to assess the association of two variables. So it means it is used to measure, it is basically used to measure the bonds. It is used to measure the bonds, the strength of the bonds. It is used to measure the strength of the bonds between the variables. Between the variables. So we normally say that the higher the bonds, the better the model. So the higher the bonds, the better the model. Now, in this case, sometimes you normally find an examiner wants you to explain. And if, for example, you get a positive correlation, So when you get a positive sign means a direct correlation, where a negative sign means an inverse correlation. So in this case, we say these two models are used to measure correlation. Are used to measure. They are used to measure correlation. One, we normally talk about product movement correlation. Product movement correlation, which is also called Karl-Pearson's. Karl-Pearson's correlation. Right? So to get this, to get our R when we are using this method, we normally take n, the summation of xy, minus summation of x, summation of y. We divide by the root of, right? N, the summation of x squared, minus summation of x, close the bracket squared, times the root of, right? And the summation of y squared minus summation of y, you close this bracket squared. You close that bracket squared. Now, when you look on the second method used, number 2, you normally look on the Spearman's rank correlation. So to get your R here, you normally take 1. This is 1 minus 6, combination of this squared, you divide by n cubed minus n. Those are the only things that I think are good for you. I'm not just going to be finding or getting a good question that we can be able to work out on it. And I will do on November 2015. But when I do all these questions, when I do that question, it means I will be able to apply all the formulas. But the questions for regression, whether from 2015 to 2022, the last semester, this question approach is the same. The only important aspect that you need to do is the identification of the dependent and dependent variables from the question. And then after you identify, then you are going to be having an easy way, right? An easy way to do these questions. So let me start by looking on a good question that we can be able to solve here. I can solve any question, even the 2022, but I think it has a lot of zeros, which is going to be giving us hard time to calculate it. So let us just look at for a question which has small figures, which we can work on straight away. So let me go to 2015 November. November 2015. So the question is here, you can read for me. Question 3B.
The table below relates to the number of units packaged by 9 casual employees of BD Limited and the packaging time taken by each of the employees. We have number of units packaged. We have time required. The regression line of packaging time against the number of units packaged.
Two, the product moment correlation coefficient. 3, the standard error of estimate. 4, a 95% percent interval estimate of the regression, 5, a packaging time interval for 7 units. So you can see we have a good question there provided. The number of units become my X, that is me identifying, because the number of units produced cannot be determining with time. Time to produce is the dependent variable, so that represents my Y. Then the other one represents my X. So in this case, when I go to my board, this is what I'm supposed to be doing. Because the first thing, examiner is asking about the regression line. And in this case, it means I have first to be writing the data provided here. So the examiner has provided us with the data. And this data seems to be looking like this. We have 1489. 1489. We have 12,611. 12,611. We have 10,510. When you look on Y, we have 230. 110, right? 230, 110, 130. 190, right? 109, 181. 181. We have 154. We have 79. And then we have 144. Requirement number 1, it needs to use as it is normally called the least-square regression. Stroke regression analysis. So we need to be forming our equation in form of Y is equals to A plus BX, where our B, we can just get it by taking N combination of XY minus combination of X combination of Y, summation, sorry. You divide by N, the summation of X squared minus summation of X. You close in bracket A squared there. Then to get my A, I take the summation of Y minus B summation of X, you divide by N. Very good. So it means here, I need to be multiplying my X and Y here. Then we need to be having my X squared. Very good. So the summation of X I can get there, the summation of Y can get there. So let me get the summation of XY, multiplication, 14 times 230, getting that 220, right? We have 8 times 110, 880. We have 130 times 9, getting 1170. Yeah. We have 12 times 190, getting 2280. We have 6 times 109.
654.
654, good. We have 11 times 181. 1991. This is 1540.
1540.
Right? 79 times 5. Getting 395. And then this one is 1440.
1440.
Squared now. 14 squared. 196. 64. 81. Right? 144. Yes, 36. 121. 100. 25. And 10. 100, sorry. Now, in this case, remember, we just need to be understanding that doing all this work is a bit tiresome in an exam. So how am I going to be dealing with my regression questions? I just want to be clicking your mode in your calculator, then regression, then we go to linear. So let us do that. We go to mode here, hub. I can see number 3 represents the regression, then number 1 represents linear, right? So I just want to be feeding this data of mine. I say, let me take 14, 230 m plus. So let me start by doing that. The first one will be 14, right? 230. Then I press, because the comma is here, the m plus is here. So I press m plus, and the calculator displays n is equals to 1. We go to 8, 110 m plus. You continue like that. 9, 130 m plus. 12, 190 m plus, right? 6, 109 m plus. 11, 181 m plus. I know that you are following. 10, 154 m plus. Then we have 5, 79 m plus. The last one is 10, comma, 144, M plus. You are getting, even the calculator is telling you our data, which is our N, is equal to 9. At we count 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is 9. So to get these values down here,
Yes.
I just need to press my calculator, shift 1. Shift 1 there. So let me press that shift 1. I will be able to see there is a summation of x squared, which is noted by 1. Then I press equal sign. I get 867. And then we go to the second one, shift 1. I can see I need the summation of x, which is noted by 2, equal sign. You get 85. Right? Shift 1 again. And then you scroll using your replay button, right? So we can scroll. We don't need y squared, but we need the summation of y, which is denoted by 2, equal to 1327. Right? Then the last one, shift 1 again. Then you scroll up to the end. Then you'll find the summation of xy is denoted by 3, then equal sign, getting 13,570. Just come and you put your data here. So n is our 9 times the summation of xy, 13,570, minus the summation of x, 85, times 1327. You divide by 9 times the summation of x squared, 867, minus the summation of x, which is here, 85 squared. So how much are we going to be getting here? To get the answers for these two, right, you just need to be clicking your shift 2. To get the answers for both, just go to shift 2, because now I can't start working on that. So shift 2, and then I scroll and I find where B is. It is in Roman 2, equal sign. My calculator gives me my answer, 16.15. Then we come and we put our A here. The summation of y, 1327, minus 16.15, times the summation of x, 85, divide by 9. Go back to your calculator, shift 2. Then we go to 1. We just need 1. Right? We get negative 5.08 or 09. So your regression line will be looking like what? Y is equals to negative 5.09 plus 16.15 x. Right? That is what and how you normally do it. That is how you normally do it. Now, from that aspect, we go to requirement part 2. Part 2, the examiner is asking the product moment correlation coefficient. And in this case, we know very well. Let me write my equation here so that I can free up some space there. Y is equals to negative 5.09 plus 16.15x. Very simple now. So if the examiner wants coefficient of correlation, to get our R squared now, we said, get my R, I need to be taking the summation of y predicted minus y mean squared. You divide by the summation of y minus y bar squared. So in this case, y predicted now, the y predicted, I can be able to predict it using my equation here. So I just come and I put it here. Y is equals, which is predicted now, negative 5.09 plus 16.15x. Remember, you have your x's here. So get your y predicted. So it means I just take negative 5.09 plus 16.15 times, the first one is 14. We get to 21.01. The second one is 8. Getting 124.11. The third one is 9. Getting 140. 140.26. The third one is 12. Getting 188. 188.71, right? The other one is after 12, we have 6. We have 91.81, right? Then we have 11. 172. 172.56. The other one is 10. After 11, we go to 10. 156. 156.41. We have 5. 75.66. And then for 10 here, you are able to get 156.41. There is no other additions that you are going to be doing there. So remember, our equation is y predicted minus our mean. So I just want to calculate my mean. To get my mean, I just need to be taking the summation of y, which is 13.27. I divide by 9. 13.27 divided by 9. And I'm getting 147.44. Now, let me have a column of y predicted minus y mean squared. Squared there. Squared. So in this scenario, this just doing this. This is what you have to do. Take 221.01 minus 147.44 squared. The first one I'm getting 5412. 5412.54. The second one is 124.11 minus 147.44 squared, getting 544. 544.29. The other one is 140.26 minus 147.44, getting 51.55. 188.71 minus 147.44 squared. I get 1703. 1703.21. 91 now, 0.81 minus 147.44 squared. Getting 3094. 3094.69 or 70. Let us use 70172.56 minus 147.44 squared. We are getting, 172.56 minus 147.44. We are getting 631.01. 156.41 minus 147.44 squared, getting 80.46. 75.66 minus 147.44 squared. I'm getting 51.52. 51.52.39 or 37. Then the last one will be 156.41 minus 147.44 squared. 80.46. So let me repeat the first one. 0.01 minus 147.44 squared. It is okay now. So what is the summation there? So plus 80.46 plus 51.52.37, right? Plus 80.46 plus 631.01 plus 3094.70 plus 1703.21 plus 51.55 plus 544.29 plus 5412.54. We are getting 22 here. 22,163.13. Now let us do the last one, which is the y minus y mean squared. Y minus y mean. The y, it is historical minus your mean. So it means the first one is 230 minus 147.44 squared. This one we are getting 6816.15. The second one is 110 minus 147.44 squared. We are getting 1401.75. Then the other one is 130 minus 147.44 squared. It is 304.15, right? Then we have 190 minus 147.44 squared. It is 1811.35. Then we have that 109, yes, 109 minus 147.44 squared, getting 1477.63, right? The other one is 181 minus 147.44 squared. We are getting 1126.27, right? Then we have 154 minus 147.44 squared. We are getting 43.03. Then we have the second last, 79 minus 147.44 squared. 79 minus 147.44, then we square. We are getting 4684.03. Then the last one now, 144 minus 147.44 squared, getting 11.83. 11.83. What is the total here? So plus 4684.03, right? Plus 43.03 plus 1126.27 plus 1477.63 plus 1811.35 plus 304.15 plus 1401.75 plus 6816.15. This is 17. We are getting here 17. 676.19. 176. Is it okay? Yes, it should. Am I getting it correct? Are we getting it correct? Let me check. I'm looking on something. There must be some addition error somewhere. So let me repeat for Y predicted. 5412.54 plus 544.29 plus 51.55 plus 1703.21 plus 3094.15 0.70 plus 631.01 plus 80.46 plus 52.37 plus 80.46. This one was wrong, correct? This one should be 16,750.59. That was wrong. So in this case, to get our R squared now, I take the predicted, which is 16,750.59. We divide it by 17,676.19. How much are you getting? So this one you divide by 17,676.19. This should be equivalent to 0.95 or 95%. 95%. 95%. That is how you do the coefficient of determination. That is how you work out on it. Now, after that, I just want to look on a computation for standard error of slope. The standard error of slope. Not slope, but the standard error of estimates, which is our SE. And we said very well, to get our SE, we are going to be taking the root of unexplained variance. Then you divide by degree of freedom. Degree of freedom there. So we said we have to be analyzing it by looking on the source. We have the amount, and then we look on the proportions. We look on the proportions. So on the source, we have explained. We have unexplained. Then we have total. We have our total there. So explained variance, you see, under our equations, the explained variance, we were able to get 16,000, right? 750.59. Then the total of hours, we were able to get 17,676.19. So when you subtract, you get unexplained. So it takes 17,676.19 minus 16,750.59. You are getting 925.60. 925.60. So if you need to get the proportions, take this value divided by the total. Let me start with what I have, 925. I divide by 17,676.19, and I'm getting 0.05. Then the first one will be 16,750.59. You divide by 17,676.19, getting 0.95. So the proportion here should be equivalent to 1. Should be equivalent to 1. So already you know your unexplained variance is 925.60. You divide by, we are talking about degree of freedom. DF, we said we take n minus k. So in this case, it is 9 minus 2, which is 7 here. So the root of this is how much? So it will be 925.60 divided by 7. So the root of my answer, I get 11.50. 11.50. That is one key. Now, in order to be able to do the confidence interval question given there, to do the confidence interval of 95%, we said to calculate it, this is what you need to do. To be able to calculate it, we said, can you be able to get the confidence interval? We say take the point of estimates, we multiply by, we add Z or T, then you multiply by the standard error of estimates. And because this data we are using here is less than 30, we are using the t-score. So I just draw my curve here. It looks like that. Then we know very well, the examiner is talking about 95% confidence interval. And I told you, just look on your tails. Look on your tails, subdivide 5% by 2. Here you get 0.025. And here you also get 0.025. Incorporate the 95% and you say 0.95 plus 0.025. We are getting 0.975. Check again the degree of freedom, which is 7. Angalia from the T table how much it is. Now 7, you remember we were able to get it somewhere. You check on the T table, you compare, and what you're going to be getting there, you're going to be getting how much? I don't know the paper that we are using has the T table. Let us check. It has just a normal curve. But I already showed you how to check on a T table. So the answer for this, the answer for our question is equivalent to 2.365. 2.365. So to get my confidence interval, very simple. The point of estimate, we were discussing about the point of the estimate, we are looking on our mean. No, not our mean. Not our mean. This is what you do. This is what you do. Let me clear here. When you look at the last requirement, there is an estimate examiner is asking there. There is an estimate. Examiner is asking you something there for the last requirement, where he is asking, right? Where is examiner is asking you, is asking this. A packaging time interval for 7 units. To get for the 7 units, I just say negative 5.09 plus 16.15 times 7. How much am I getting? So 16.15 times 7 minus 5.09. We are getting 107.96. So to get my confidence interval, I will be able to take 107.96 plus or minus, right? Plus or minus 2.3, which is the value of t, times the standard error of estimate, which we were able to get is 11.50. Remember, we are going to be having two solutions, the upper limit and the lower limit here. The upper limit and the lower limit. So let me start with the upper limit. The upper limit will be 107.96 plus 2.365 times 11.50. I'm going to be getting an answer there. Then for the lower limit, we have 107.96 minus 2.365 times 11.50. Right? So how much am I going to be getting there? Now let me start with the upper limit. 107.96 plus 2.365 times 11.50. We are getting 135.16. The other one will be 107.96 minus 2.365 times 11.50. We are going to be getting 80.76. 76 there. I know the examiner can be able also to ask you to calculate the coefficient of correlation. I know it is the one that is not factored under this question. So to calculate the coefficient of correlation, and I will be able to show you whether you go to your R squared based on our calculation, kama tulipata the R squared correctly, right? Tutaenda hapo kwa calculator tuangalie. Kwanza waje tufanye nini? Y squared. Y squared. So let me just close this one. Y squared here now. So let us get the column for our Y squared here. Y squared. Sasa, mimi sitashinda nikimultiply because already I can get my Y squared from the calculator. Right? So mimi naenda kwa shift 2, nitafute 2Y squared. Shift 2, nitafute Y squared iko wapi? y squared. Shift 1, sorry. After y squared is 1. Getting 213. 213. 335. Why am I getting y squared? Because to get my coefficient of correlation, coefficient of correlation, I need to be taking n, the summation of xy, minus summation of x, summation of y, you divide by the root of n, the summation of x squared, minus the summation of x, you close the bracket squared, times n, the summation of y squared minus the summation of y, you close the bracket squared. Now, in this case, that is the reason I was looking for y. And when I look on my n, it is 9 times the summation of xy, we were able to get 13,570 minus the summation of x, 85. Summation of y, 1327. You divide by, right? The root of 9 times the summation of x squared. X squared of ours is 867 minus the summation of x, 85 squared, times, right? The summation of y, the 9, the summation of y squared, we are getting 213.335, sorry, minus summation of y, 1327, 1327 squared. Sasa hii pia naenda kwa shift 2. Shift 2. Natafuta r maliko 3. I'm getting my r as 0.97. 0.97. Remember now, ukiwa already uko na requirement hizi mbili, coefficient of correlation and coefficient of determination, just calculate coefficient of correlation first. You see, it is simple. It is simpler compared to the coefficient of determination. Then you square this one to get the r squared. Let us look on whether the r squared you are able to get. Just square your answer. You are getting 0.95. And that is what you are able to get after you do all those calculations. Now, the only thing that I have not calculated, remember here we have calculated using the Carl-Pearson's method. Carl-Pearson's method ndio tumetumia hapo. What about when they are asking a question regarding to Spearman-Rank correlation? That is something that I have to teach you right now. So let us look on when they are asking a question in regards to a Spearman-Rank correlation. To give you an illustration or assignments here, you can go and try May 2017. May 2017, question 1B. The whole of 2021 and 2022. You can go and do those questions for this topic. Now, the only thing that I just need to teach you, right? It is about Carl-Pearson's. And this is how you normally do it. Spearman's rank correlation. This is done. This one is done and dusted. So the only thing that you need to understand here is how to calculate the Spearman's rank. And because this topic is all about mastering the formulas and how you can be able to apply the question, I'm hoping that you are going to be repeating it much. So I just want to look on Spearman's rank correlation, which is my R now. So to get your R, we said you take 1 minus 6, the summation of this squared, minus, divide by n cubed minus n. To do this, we just need to be looking on May 2017 question 4B. May 2017 question 4B. So let me check on it here. May 2017. Question number So you can see the questions there for regression are many. You can just go and try it. So we are talking about 4B. 4B is here. So we have been to the table below shows the marks scored by 8 students in mathematics and English subjects. So we have been given the students mathematics scored in the marks scored in mathematics, marks scored in English. Required there, the rank coefficient of correlation, and we interpret our results. So in this case, you normally go to your calculation or to give out the solution by doing this. I think you have not seen the question, right? So this is the question. So the examiner has given you the marks scored in mathematics, marks scored in English. So you can see the examiner required is asking for the coefficient of correlation, and then you interpret the results. And these are free marks because this is what you normally do. This is what we normally do. So in this scenario, you just come here, you say, let us start with maths. Let me copy maths. So marks scored, we have 31, 36. 31, 36. We have 44, 28. 34, 44, 28. 56, 76. 56, 76. 36, 96. Let us rank. Right? Let us rank. So the first one is 96. The second one is 76. The third one is 56. This is the fourth, right? 4. Then we have 236, which are occupying number 5 and 6. Then you divide by 2. Whether they are 3, you can take 5, 6, 7, you divide by 3. So in this case, we are getting 5.5. Kuja hapo uniwekee hapa 5.5. Na hapa pengine 5.5. Then remember utaenda number 6, tunaenda 7 sasa because already umeshatumia 6. This is 7 na hii ndio number 8. Let us go to English. Our English now, we have 56, 46, 66, right? We have 46, 36, 46, 36, 26, 46, 76. Number 1 here, when we rank. This is number 1, right? Number 2, where we'll go up. We have number 2 here, right? We have, this is our number 3. Then we have number 4, where are you? You can see we have 3 number 4s. So we have number 4 plus number 5 plus number 6, because we have 3, 46. Then we divide by 3 here. So how much is this? This is 15 divided by 3, which is 5. Unaniekea hapa 5, 5, and 5. Then this will be number 7 now, because already we shatumia mpaka 6 and 8. Look on the difference here squared. The difference of your ranks. The difference of your ranks. So the first one will take what? So the first one will be 3 minus 4, which is 7 minus 4 minus 3, which is 416. This is 0.25 because it's 5.5 minus 5 squared. You get 0.25. The other one is 24. This one is 3, 9. This is 4, 16. This is 6, 36. Right? This one is 0.25 and this one is 0. So how much is this? 16 plus 0.25 plus 4 plus 9 plus 16 plus 36 plus 0.25. We are getting 81.5. That is our D squared. Now, remember our formula. To get your R, you take 1 minus 6 times 81.5. You divide by n cubes. N cubes. 1, 2, 3, 4, 5, 6, 7, 8. 8 cubes minus 8. So, times 6 here. Then you divide by 8 cubes minus 8. 8 cubed minus 8. I'm getting that. So it will be 1 minus 0.97, which should be equal to 1 minus answer. We are getting 0.03. 0.03. 0.03. Have you understood?
Yes.
Very good. Very good. That is the end of the regression. Correlation and regression analysis. I know there are many questions. You can just be able to look at them. Whether May 2018 question 4B, you can go and try to look at that question. May 2018 question 4B. That is a good question there. Now, as per my syllabus, I think what is remaining right now, we are remaining with the hypothesis testing. We have decision theory. These are very short topics. We have linear programming. We have linear programming. Then the last topic will be which one? Time series. So we have done a lot. So these topics can be combined one day and we finish. We can just combine. They are very small topics. For hypothesis, it's just some few things there. Actually, is to show you how to do the question. The decision theory is very short. Linear programming was shortened by the revision of the new syllabus, so it is very short. By looking on the graphical and linear, then I think a bit of time can be taken when you are calculating the time series, so that you are able to do your question. Or I can be able to subdivide them to, we do like what we have done today. One, we do the early morning, we break. Then the other ones we do later on, and then we finish. Is that okay?
Yeah, it's okay.
Good. I think that job will be done on Sunday. On Sunday, I will be able to finish your syllabus in that manner. So just be ready, take your revision very well. The videos I will be able to upload and make sure that you can be able to access them. So let me stop at that point and thank you for your participation.
Mwalimu, you can share the notes with me.
The notes for?
In the morning, you
You
said
don't
you
have?
have some. In the morning, you said you will share some notes with me.
Oh, yeah. I will share the notes
Remember
for
in our morning session.
set theories, probability distributions. I will be able to do that. Yes, I will share. Just remind me tonight, around 9 there. Because there is somewhere I'm rushing. So just remind me around 9, I will be able to share them.
It's okay.
Okay, good day.
Good day too.